Aside from being 110 volts or 120 volts plus or minus versus or juxtaposed to the 220 volts, question, what are the differences here? A good way to, perhaps I'm not certain if good way is a good terminology, but an outside of the box way to look at a contactor to understand the concept of a contactor. Now keep in mind this would run off of 120, this would be 240, so this forget the voltages here. But when this light switch, when one wants to throw it on or off, they would simply just go over here and flip the button. That would flip it on, flip it off. Okay, this is a mechanical thing. This would split your hot. So I think this may be a three-way switch. So this is probably not the best of demonstrations. So the question is, this would be mechanically. So what we're doing is taking electricity from one area to the next area. Say if this was just an example here. Okay, over here what we have is we have two low voltage wires, either a yellow or a red and a blue, hypothetically here, running 24 volts. So when the 24 volts pulls in, once the contactor pulls in, it pulls the 24 volts in, and then as one can see here, the contactor will pull in. It's difficult to see here. Okay, when it's de-energized and you no longer call for this, say the thermostat calls for something, and then it's satisfied, the temperature is satisfied, so then there's no voltage, then it simply pops up. It's kind of spring-loaded here, as you can see. So the low voltage on the side, the 120 and 120, the 240 on top. So the question here being a light switch versus a contactor, what are the differences? Okay, just as an example, they basically just cut on and off electricity. This you manually throw up or down to, say, kill the electricity. Well, this is a three-way, so it's a little bit different. It would be probably a better example if it was just a regular switch. I think this may be a three-way, I'm not certain. But anyway, notwithstanding, we just flip this with our hand, so it's either on or off. So then, okay, but over here, this is electrically low voltage energized. And once it's energized, so one does not have to have a switch to come through it. When this low voltage and this low voltage side here energizes this coil and it pulls this coil in. Once it pulls the coil in, it pulls it in. You go from 120, 120 to 120, 120. So then you go basically that goes from runs you to say 240 volts. And basically, so it's just a method of moving electricity. This is a mechanical switch that you do, but I'm not sure if mechanical is the right word, but it manually, you can flip this switch manually to turn the light on and off. Over here, this is low voltage. Low voltage, when energized, will turn this on, will allow this, convey this electricity to here. When it's turned off, the electricity should be live on one end, but dead on the other end. Now, if it's, one caveat here, if it's live all the time in your motor and your fan, those contacts may be welded shut and it may be a bad contactor. So basically just the differences between a light switch and a contactor to kind of get an overall understanding of a contactor for heating and air conditioning, primarily residential uses. Thank you for watching. Have a great day.